Okay, so for today we are going to look at acids and bases. So when it comes to acids and bases, what are we going to talk about? We're going to talk a little bit about your acidic reactions, right? What makes an acid acidic? And then we're going to talk about metals and your metal oxides and your bases. So when you come into the first part, what we're going to study, this is an overview. So there are three main reactions that we're looking at. Metal plus acid, carbonate plus acid, and then base plus acid. So before we can do the questions related to acids and bases, we need to understand who are your important acids. So there are a few of them here that you must memorize. So HCl, hydrochloric acid, your sulfuric acid, your nitric acid. These three, you must know them at the start. Okay. Further on into this chapter, you'll learn about ethanoic acid. Okay, but we'll focus on the main three on the left first. So when it comes to your ions, it is also important for you to memorize the ions because we will be doing a lot of chemical equations and you'll be expected to be able to score your chemical formulas accurately. So for your sulfate, there's a charge of 2-, nitrate has a charge of -, carbonate has a charge of 2-, hydroxide with a charge of -, ammonium with +, and phosphate with 3-. For today, we are going to focus more so on sulfate, nitrate, carbonates, hydroxides, and ammonium. So these 5, you must be familiar with them. So moving on to the first part, we have a metal plus acid. So this is the first equation. So in the general equation, what does metal plus acid give you? It will give you a salt plus hydrogen gas. Okay, so at this point in time, I'm not sure if you guys still remember how to test for your hydrogen gas. To test for your hydrogen gas, you will always use a lighted splint. Okay, and the lighted splint will extinguish, okay, with a pop sound. Okay, and that's how we test for hydrogen gas. So other than that, there's this thing called a salt. So some of you may be wondering what exactly is a salt. So a salt is similar to this. So let me show you something first. So when it comes to acid, we have things like HCl, HNO3, and H2SO4. So what exactly is a salt? Okay, so the common feature of an acid is the hydrogen over here. So when you replace this hydrogen with, let's say, Na, K, and let's say Mg, okay, I have replaced their hydrogen. So what you can see is that when you replace the hydrogen of an acid, you will actually get a salt if you replace it with a metal. Okay, so I hope that helps to explain what exactly is a salt. Okay, now, so if it's all is good, okay, let's take a look at this sample equation. So over here, you have magnesium reacting with hydrochloric acid. So what's going to happen is you will take the magnesium and you'll replace it with the hydrogen here. And of course, Mg is 2+, Cl is -, and therefore you'll get MgCl2. Okay, so pay attention to the charges of your ions. So if you guys are okay, then I want you guys to try these 4 equations here. Right, help me to write them out in full. Okay, so at this point in time, give the students some time to actually write out their equations. If they are relatively weaker, you can always help them with the first one and then get them to do the second and third one. Okay, so once they are done, okay, you will mark through their paper, mark through their equations, and you'll be like, okay, that's good. So one last thing to conclude over here is that sometimes metals tend to be a little bit unreactive. Okay, so which kind of metals? Such as copper, silver, and gold. So because they are unreactive in nature, they do not react with acids. Okay, so to be very accurate, they do not react with dilute acids. Okay, but if your acids are concentrated, then it may react. Okay, so if all is good, let's take a look at the next equation. So the next equation will be on your carbonate plus acid. So what happens here is that when you take a carbonate to react with an acid, you'll get salt, carbon dioxide, and water. So same thing, right? There's a sample equation here. Sodium carbonate reacting with nitric acid. So same thing, take the metal, the Na, replace it with the H, and there you go, you'll get your salt. Okay? So if all is good, same thing, help me to try the 4 equations over here. Okay, so once the students are done, you make sure you check through, and then go through with them the last part. Okay, so if you still recall, to test for carbon dioxide, okay, we'll use this thing called lime water. So we will bubble your CO2 through your lime water, and then you'll see a white precipitate. Okay, so some students may say that, oh, the lime water turns chalky, it turns milky. They're not wrong, but we no longer use that in your upper sec, in Sec 3 and Sec 4. We have to use the word white precipitate will be produced. Okay, so once they are done, move on to the next part. Okay, so students, now let's come to the last reaction. We're going to talk about your base plus acid. So when it comes to your base plus acids, generally there are 2 types of bases. Right? One is a metal oxide, one is a metal hydroxide. So let me give you some examples. Okay, metal oxides will be things like Na2O, MgO. Metal hydroxides will be things like NaOH, right, and Mg(OH2). So the only difference here is that some of them are soluble, some of them are insoluble. Okay, but nonetheless, whichever that reacts with acid will give you a neutralization reaction. Okay, so over here, let's have a base plus acid. When you have a base plus acid, you'll get salt and water. So same thing, an example here is sodium hydroxide reacting with hydrochloric acid. So take the metal, replace it with the H, you'll get your salt. Okay, so same thing, help me to try out these 4 equations here. Aluminium oxide, right, and magnesium hydroxide reacting with the reactants over here on the right. Okay, so once the students are done, give them some time to finish up everything, check through, and then you can move on to the next part. Okay, very good. So now that we have learned the 3 different equations, we're going to talk a little bit about this thing called neutralization. So why do we call a reaction a neutralization reaction, especially for an acid and base reaction? It's because water is produced. Water is neutral in nature, so that's why when you produce water, we call it neutralization. Okay, so other than that, let me talk a little bit about pH. So pH 7 is what we know as to be neutral. Anything more than 7 is basic. Anything less than 7 is acidic. Okay, so more than 7 is basic. Less than 7 is acidic. So right now, we have this thing called your ionic equations. So when it comes to your ionic equations, you guys will have to learn it in a different chapter. But for now, one thing you guys can do is to actually memorize how do you get your ionic equation for neutralization. Okay, it will always be the same as H plus OH minus to give you H2O. Okay, so at this point in time, take your time to actually look what I have written here. I will actually take the opportunity to actually run through some of the things about your pH scale and universal indicator with the students. Okay, so let me show you how I'll teach it. Okay, so with regards to all these, right, we talked a little bit about pH, agree? So when it comes to pH, what is the range of pH? So you realize that pH ranges from 0 to 7 to 14. Okay, so what is 7? 7 is neutral, right? So what about 0? 0 is actually a strong acid, right? And 14 will be a strong base or alkali. So anywhere in between, right, okay, will give you your weak acid and your weak base. Okay, so apart from your pH, right, there's this friend that we know is called your universal indicator. So what does your universal indicator do? Okay, so your universal indicator actually gives you different colors, right, when the pH of that solution is of a certain range. Okay, so depending on what pH it is, the color will change respectively. Okay, so what's one easy way to memorize it, right, is to actually remember the colors of the rainbow. Okay, so if you remember the colors of the rainbow, it goes something like this: red, orange, yellow, green, blue, indigo, and violet. Okay, so yes, I'm missing your indigo, but you will realize that this is the order for your colors of the rainbow. Okay, so you'll see here that pH from 0 to 2 will be red, 3 to 4 will be orange, 5 to 6 will be yellow, and 7 will be green. So 8 to 11, right, will be a blue, and 12 to 14 will be your violet. Okay, so once you guys are done here, you can let your students try some questions. Okay, so which question will we be doing? Okay, let's take a look. It will all the way behind. Okay, over here, on page 18 and page 19. So on page 18, you will do this. Okay, question 12. Alright, and over here, page 19. Okay, so page 18 and page 19. Okay, so get your students to do page 18 and 19. Okay, so once they are done, check through. Okay, and then we'll move on to this part. Okay, so next. Okay, so now that we have learned about your pH and the 3 basic acidic reactions, let's talk a little bit more about acids. Okay, so have you ever wondered what makes an acid acidic? Okay, so let's take a look at the first statement here. Is that acid molecules will only liberate H plus ions when they are dissolved in water. Okay, so let's break this down. What do I mean by liberate H plus? So for example, things like HCl will actually break down to give you H plus and Cl minus. And this is exactly what we mean by liberate H plus. Right, so this only occurs when it is dissolved in water. So meaning, right, that if HCl is not dissolved in water, this will not occur and we will have no H plus ions. So why are we so concerned about these H plus ions? It's because these H plus ions is acidic. Okay, so that means HCl is not the acidic guy. The H plus that he produced is the acidic one. Okay, so only when you have H plus, then you'll show acidic properties. And therefore, you will never ever be acidic when you are dry or if you are dissolved in a liquid that is not H2O. Okay, so remember that if you do not dissolve in water, you will never have H plus ions. Okay, so because of H plus ions, do you agree with me that the more H plus ions I have, I will be a stronger acid and I'll have a lower pH? Okay, so using this, let's take a quick look at a very small example of HCl and H2SO4. So just by looking at the formula, you'll realize that H2SO4 will actually be the stronger acid because he has more hydrogen. So in this case, we can classify H2SO4 to be dibasic, while you can classify your hydrochloric acid as monobasic. So dibasic meaning that he will release 2 H plus per ion, per molecule, and monobasic meaning he will release 1 H plus per molecule. So because of this, the concentration of H plus will always be higher in H2SO4, and H2SO4 should be a stronger acid, given that both of them are at the same concentration at the start. Okay, so if you are okay, let's take a look at the next page. So I mentioned monobasic and dibasic, so you can see here, 1 H plus per molecule will be things like HCl and HNO3. Dibasic will be 2 H plus ions per molecule, it will be H2SO4. So generally, right, these two, right, will be the ones that we'll be focusing on. On the tribasic one, we won't really talk much about it, but I just want you to pay attention to monobasic and dibasic. Okay, so once you're okay with this, you can give your students a couple of questions to try. So let me show you guys which question your students will be doing. Okay, so you will get them to try this question here on page 20. Okay, so just this question on page 20 and then you can proceed back. Okay, so I write down here, page 20. So once they are done, check through and then you can come back to teaching. Okay, so this is the next part. Okay, so students, good job. So after you have done a couple of questions on your acids and understood what makes an acid acidic, we're going to go deeper into acids. Okay, so what types of acid do we have? So generally, there are 2 types of acid. We have your mineral and your organic acid. So to cut the chase, take a look at this. Your mineral acids are what we call to be strong, and your organic acids are what we call to be weak acids. So what do we mean by strong and weak acids? Okay, so if you take a look at what is a strong acid, it says that they will have a high level of dissociation. So to be a little bit more accurate, I would say that there will be complete dissociation. So what do I mean by complete dissociation? Okay, so if you take any of the acids that is written here, so for example, HCl, HCl will dissolve in water to give me H plus and Cl minus. And this is what we mean by dissociation. But what do I mean by complete dissociation? So for example, if I have 100 HCl and you dissolve it into water, you will also get 100 H plus and 100 Cl minus. Okay? So this shows that 100% will dissociate to give you H plus. So because of this, your acids that are strong tend to have higher concentration of H plus ions. Okay? So now let's take a look at your organic acid. Okay, so organic acid, right? The acids are going to look a little bit weird. So you have this thing called ethanoic acid. So let me explain a little bit. So these kind of weird acids that you have tend to be weak. Why? Because they have low level of dissociation, which means that they will only partially dissociate. So what do I mean by partially dissociate? So for example, you have ethanoic acid, CH3COOH. Okay, although he has a lot of hydrogen, not all hydrogen it participates to become H plus. Okay, so take a look. He will actually become CH3COO minus and Na, and you have a H plus here. So when I mean by partial dissociation, right, you can take a look at this. For example, if I have 100 ethanoic acid that will dissolve in water, not all of them will dissolve fully. So meaning that maybe I only have 2 of this that actually dissolve fully. So this actually shows how your ethanoic acid is actually a weak acid in general. Okay, so this is what we mean by partial dissociation. Okay, so if you only partially dissociate, then you will tend to have much lower concentration of H plus, and that's why you are a weak acid. Okay, so once you guys are done with this part, your students can actually try some questions. So let me show you guys what questions I tend to give my students. Okay, so you can get them to try the question here. So this is on page 15 and page 16. Okay, so these are the 2 questions that you want them to focus on, page 15 and page 16. Okay, so if you have a little bit of time to spare, you can always get them to do page 13. Give them a little bit of a thought process to try it as well. Okay, so 13, 15, and 16. So 15 and 16 is the priority. So I write it down here, page 15 and 16. Then if you have extra time, page 13. Okay, so once the students are done, okay, I'll generally skip the next page and I'll come to this part. Okay, so now let's talk a little bit about oxide. So this is the final part. And this is the part where many students find it difficult to understand. Okay, so let me try and break it down a little bit for you over here. So first thing we're going to talk about is your metal oxides, which means that I kind of have an ionic compound. Why? Because it is a metal plus non-metal. Okay, because your oxide means oxygen. Okay, so if you have ionic compound, you will tend to have high melting and boiling point, alright, and that will actually tend to exist as solids at room temperature and pressure. Okay, so that's just a general thing for you. Other than that, when your metal oxides when it comes to your metal oxides, they have 2 kinds. Some of them are basic. Okay, in fact, most of them are basic, which means they can react with acid. But some of them are a little bit special. They are amphoteric, which means that they can behave as both acids and base. So they can react with both acidic and basic oxides as well. Okay, so I'll share more about these with you in a bit. For the next one, we have non-metal oxides. So because we have a non-metal plus another non-metal, then you will actually get your covalent compounds. So remember, covalent compounds tend to have low melting and boiling point. So that means they tend to exist mostly as gases at room temperature and pressure. So for these non-metal oxides, most of them are acidic in nature. So because they are acidic gases, right, you will have to remove them by bubbling them through NaOH, right? And NaOH is your alkaline. Okay, And apart from some of them being acidic, of course, some of them are special. They are neutral, so they will not show any acidic or basic properties. So if you take a look at this flow chart, it more or less shows you everything that you need to memorize. But let me make your life a little bit easier. Okay, so I will sketch out a little bit of a periodic table for you. Okay, so this is kind of a sketch of how your periodic table in school looks like. Okay, we have your staircase. So if you want to find a basic oxide, you will tend to choose, elements that's towards the left-hand side. Okay, so most of the basic oxides will be found on the left. Your amphoteric oxides tend to be towards the middle. Okay, right, you can take a periodic table and check, okay, like zinc, aluminum, lead, beryllium, and tin, all these are towards the middle. And then your non-metals, right, okay, will actually give you your acidic oxides. Okay, so what about your neutral? For your neutral oxides, they will actually be just your non-metal, right, but they won't just be any non-metal oxides, they will be your non-metal monoxides. Okay, so the key word here that I'm stressing is monoxides because it means that they have singular O. So if you look at your neutral oxides, all the O's are neutral, right? So you see your water is neutral, right? Carbon monoxide is neutral, and nitrogen monoxide is also neutral. Okay, so with that, okay, that is more or less it. Then you can get your students to try questions. Okay, so after this, right, the question that they should do, okay, will be over here on page 18. So the question on top of page 18. Okay, and once they have done this, okay, you're more or less done with the whole teaching over here. You can actually get them to try the other questions here. One notable question you can get them to do is question 12 as well. But this chapter will bring in, this page will bring in a little bit more. Okay, so you can do your page 18, right, and then your page 12. Okay, and that is the minimum that they should do for this whole chapter. So this chapter is a bit long. You may not be able to complete it in one setting, right? You can feel free to split this into 2 parts. Okay, so with that, that is all for this chapter.